Okay, you're asked to find the electric field at a position vector 2, 1, 0. Should be centimeter here. So which is the same, so all throughout will be in centimeter. From the origin due to a charge of 5 nanocoulombs at position vector 1, 1, 1 centimeter and a charge of 2 nanocoulombs at 1, 0, 1 centimeter. Okay, so that's the first part, to find the electric field. Okay, we start off with, so let's put this to a diagram. There we go, P, our position of interest, and then we have two charge, Q1, Q2, and this is my origin. So I got R2, R1, this will be R3. So this is where our charge is, and then we define our vector from the charge to the point of interest. So this will be a vector Q1P. Then this is another vector from Q2 to P. Okay, so Q1P, vector R3 minus R1. There will be 2, 1, 0 minus 1, 1. This gives us 1, 0 minus 1. And this is in centimeter. And then the unit vector divided by root 2. And then the other one, Q2P, equals to R3 minus R2. And the unit vector Q2P Okay, then we can write down the electric field. So we call this due to Q1, we call it E1. That will be Q1 or 4 pi epsilon naught. And then that will be the magnitude of Q1P squared times the unit vector Q1P. Q1 is 5 nanocoulombs. It will be 10 to the minus 9 over 4 pi. Epsilon is 8.854 times 10 to the minus 12. And Q1P is root 2 centimeter, so that 10 to the minus 2 squared. Then our unit vector is 1, 0, minus 1, root 2. This gives us 1.589 times 10 to the 5. 1, 0, minus 1. Per meter. Then we can do the same for E2. So it will be Q2. Again, 4 pi epsilon naught. Magnitude of Q2P squared. Unit vector Q2P. This is equals to, this is now 2 nanocoulombs. 2 times 10 to the minus 9. 4 pi 8.854 and to the minus 12. And root 2 times 10 to the minus, so 10 to the 2. Sorry, it's 10 to the minus 2. Squared. Then the unit vector is 1, 0, minus 1 over root 2. No, actually it is an error here. No one spotted it. So our Q2P is not 1, 0, minus 1. Okay. So R2 is not 1, 1, 1. R2 is given as 1, 0, 0. So this will be 1, 1, 0. This 1, 1, 0, 1, 1, 0. And this should give you 6.355 times 10 to the 4, 1, 1, 0. So the total electric field will be the vector sum of E1 plus E2. That will be 1.589 times 10 to the 5 0 minus 1.589 times 10 to the 5 plus 6.355 10 to the 4, 6.355 10 to the 4, and then 0. Adding this will give us 2.225 times 10 to the 5. .355 times 10 to the 4 minus 1.589 times 10 to the 5 per meter. Okay, so that is the electric field, which is the first part of these questions up to here. Any questions so far? So the second part is if we put a charge of -2 nanocoulombs at position P and calculate what is the force acting on the charge. So if we put a charge here, -2 nanocoulombs, and what happens to this charge? Okay, so at P, we have the electric field calculated as so this is the electric field at point P. So if we put a charge at this point as -2 nanocoulombs, the force will be Q times the electric field. This will be -2 times 10 minus 9 times ET, which is the total electric field, which is this here. So I'm not going to rewrite that. So just multiply it with -2 times 10 to the 9. That will give us minus 4.45 times 10 to the -4 minus 1.27 times 10 to the -4, and then 3.18 times 10 to the -4 Newton. Okay, you can either present the result as this, or you can calculate the magnitude of the force, okay, which is square root of squared plus minus 1.27 10 to the minus 4 squared. Give us 5.62 times 10 to the minus 4 Newton with a unit vector minus 0.792 minus 0.226 0.566. So either you give your answer as a vector, something like this, or if you give in magnitude, then you have to give the direction of the vector as well as a unit vector. Okay, that is the second part of the equation.